Hi class, Alan here, coming at you with the last section of this chapter, talking about more applications of these right triangles that we've been talking about in depth. So not too much in this one, but this is where some students will struggle a bit simply because of the nature of these. And so we'll get to that right now. So before we get to the topics of today, I wanted to start you guys off with a story about the power of knowledge, and I'm emphasizing that it is mathematical. There was a guy by the name of Regiomontanus, quite a name there, who actually was very much interested in both math and astronomy. And he wrote many books, and you can see the date here. Back in 1474, he printed, go ahead and try and say that, Ephemeridus. Don't quote me on that. And basically, he was talking about the position of the sun, the moon, and the planets in his work. And Christopher Columbus, a guy you guys may be familiar with, actually had a copy of it on his fourth voyage to what was then called the New World. And he actually used that to a great advantage of his when he met and had arguments with the indigenous people, the Indians, that there would be a lunar eclipse on February 29th, 1504. And again, this was all based on Regiomontanus, his book. And basically, what he said was, you know what? You're going to give me food and water for my people. And if not, then God is going to punish you and take away the moon's light. And at first, of course, the indigenous people were like, yeah, whatever. That doesn't make any sense. Ever since we've been here, we've seen the sun and the moon every day and every night. But at that time, in February 29th, 1504, when the eclipse began to happen, just like Regiomontanus stated, they were terrified. And they gave them everything that they wanted, and the rest is history, literally. So, again, this is a nice way, a little story to show the power of knowledge. And if you study enough, you can actually use this to your advantage, which many people often do, namely with statistics and math. Okay? So, nice little story there to get us started. Now we're going to talk about Columbus a little bit more in the fact that we're going to be talking about this thing called bearings. And bearings, you may have heard before, it's used loosely to get your bearings, is to kind of get your feet under you, understand where you're at. Well, this is often used either at sea or even with airplanes, because for them it's hard to get their bearings. You can't just say, hey, you know what, make a left at Wendy's and then you'll be right there at Fresno City College. It doesn't happen. Okay, so you got to make sure that when you're talking about bearings, because there's nothing really to make a reference when you're out in the middle of the ocean or up in the sky, that we have some way, some form of figuring out a direction. And that's basically what bearings are. Okay, so for us, there's actually going to be two different types of methods that we're going to look at and use. And then we'll talk about some real life word problems that we'll be dealing with and trying to answer certain questions for. Okay, I'm going to say that there is an absolute must that you draw it correctly, and then don't forget to label it, meaning drawing it correctly, so that you can actually find the answers for the task at hand. All right, so let's get to the two different types. We're just going to call loosely method 1 and method 2. So for method 1 here, we're going to be using a clockwise direction from the north. So for every single one of these, we're going to start by looking north looking north, and then they're going to give us an angle after we're looking north, and we are going to go clockwise, again, to the positive direction. Now, normally we start on the x-axis from our origin, and then we rotate up. That's normally the direction that we go, and that's the positive. This time we're going to be always starting north and then rotating clockwise as our positive direction. So a 32-degree bearing would be here, starting north and rotating 32 degrees to the right, the positive direction. 164, again, starting north, rotating there, almost 180 degrees. 229, 304, you kind of get the picture. And if you wanted a little bit better picture, what you could do is start drawing your axes so that you can see some of the triangles that we'll be creating, again, always to that right angle x-axis. So that is method one that we will utilize quite often. And again, like I mentioned, it would be really nice if you could draw your 4 quadrants and do the same type of ideas that we've been doing in all the previous sections. Method number 2, how is it different? Well, actually, this is probably my preferred method in the fact that when we're looking at method 2, it will tell you a little bit easier where you should be looking to start, how much you should rotate, and in what direction. So we're always going to start with a north-south direction. Then we're going to provide an acute angle, which is really nice because remember, acute angles are between 0 and 90. So we're just going to be working with angles that are smaller than the previous 304, 229, 164. We're going to be working with all acute angles like that 32. So here are some examples for all 4 of our different quadrants that we would have. The first one, north 42 degrees east. Okay, so if we're dealing with this, they're telling us start by looking the way that we read this, north. So the first thing we would do is look in the northern direction. Then it's going to tell us to rotate 42 degrees, but we need to know, is that to the west or is that to the east? In this case, they are obviously telling us rotating to the east, which means this direction. And that would be our point of reference, our bearing, we call it, for the direction that we would be facing. So why did they choose north or south first? We just had to choose. And since the other method always uses north first, probably because of the North Star out at sea, because of our compasses, then we're going to make sure that when we do method 2, we always use the north or the south. So looking at the next one here, it says to start by looking south first, rotate 31 degrees second, and in the eastern direction, so to the right. All right, so for all you Kardashian fans out there, there's your northwest. All right, and we can put you in any quadrant. The nice thing about these, we will have an acute angle only compared to the other ones that can be a full rotation of 360 degrees from the north, moving clockwise, not counterclockwise like we have been in the previous. All right, so not too bad. One little word of caution before we get to the examples: labeling doesn't have to be drawn to scale, but labeling your graph, your sketch, is going to be crucial when working these out. All right, one of the most difficult parts about these is taking that short paragraph or few sentences and rewriting it in terms of, hopefully you know, either a nice graph, which what are most of your graphs going to always turn out anyways, since you're in a trigonometry class? A right triangle. And then setting up an equation that you can then solve using the given parts in order to find that length or that angle that they're going to be asking us to find. All right, so let's go ahead and give this a shot and see how we can work these up, and we'll start off a little bit easier and work our way to more difficult types. So before we actually get to the word type problems, let's start with just drawing these correctly. All right, because if we can't do that, then it's going to be very difficult to set these up given just word problems. So the first one here, 47 degrees. Now, if that's the only thing they gave us, what did we say that we would always start by looking? North. Just remember that North Star on your compass. Picture that first. So we're going to start by looking north, and we said we'd always go to the positive direction first. So when we were starting on the x-axis, we knew that that was going to be up and rotating that way around. But because we're rotating from the north, we're going to move to the right, which is also the positive direction. So in order to do that, I know 47 is right about in the middle. 45 would be right there. So this would be 47 degrees. And because I've drawn my quadrants out, I already know that this would actually have been a right angle. And so if I needed, I'm not sure because we haven't gotten there yet, but if I needed to know that other angle, then hopefully you would know it's just 90 minus 47. We know 90 minus 40 is 50, minus 7 more is 43. So when you're working these word problems out, it's best to label as much as you possibly can because you never know what you're going to need. Okay? So our answer is simply to that point. That would be our bearing for a 47-degree angle out at sea or in a plane. So the next one, 132 degrees. If you want to try any of these other ones on your own, go ahead and pause it here. Otherwise, I'll go ahead and keep working through them. 132 degrees, again, starting to the north. And then I know I'm going to rotate to the right positively, but am I going to go a full 180? No. I'm going to have to come back a certain amount so that I can go 90 plus how much more? 42 degrees would be how much more I'd have to go to get to that 132. So that then tells me the direction that I would be going to get to that point or continue on that path. Well, then how about 257? Remember, we're going to start north again. And this time I am going to rotate more than 180, but am I going to go 270? Not quite. How much less is that? Well, then just subtract it and you can see. We know the 200s are going to cancel out, so we're really just doing 70 minus 57. And so we know 70 minus 50 is 20, minus 7 more would be an angle of 13 degrees right there. Now again, if I wanted to know what it would be for this angle, then I can just take 90 minus 13 because I know together that those are complementary. So 90 minus 10 is 80, minus 3 more, that would be a 77-degree angle. So labeling anything and everything that I possibly can. Obviously, I don't need to keep doing all of those 90s, but we could. Okay, last one here, 315 degrees. Again, starting due north, and then I'm going to rotate almost all the way around. That's 270 right there, and all the way around would be 360. And hopefully you recognize 315 as one of our nice reference angle in a different quadrant. 315 is that 270 plus 45 degrees. That would give us our 315. So I'm looking at doing right in the middle of quadrant 2, that 45-degree angle on top of the 270 to get to that point or that direction. Okay, so not too bad. For example 1, just getting the hang of when we only see one angle, we will face the way that 1 points north. Okay, and then rotate to the right, always positive direction. So example number 2 wants us to list the angles using the bearings method 2 now for the same angles we just sketched from example number 1. So using those, I'm going to go ahead and grab all of our drawings real quick and set those up. And now we can put all of these into the alternative form, which remember were originally given to us as. So we now need to write all of those angles, which we pulled the graphs from above, and the angles in method 1 of bearings to rewrite in method number 2. So remember, there are 3 parts to these. So for the first one, 47 degrees, we know that we're going to start in the north-south line, and in this case, the north. That's going to be our first direction we're going to start, and then we're going to have to rotate 47 degrees to the east. And that's it. Those are equivalent. So which one do you prefer? Totally up to you. I think one is definitely easier than the other, but it's all a matter of preference. So go ahead and pause it, see if you can do the other 3. If not, I'll continue explaining them. If you need to come back and get a little explanation if you're not quite sure. Otherwise, should be pretty easy, not too bad so far, only in our second example. 132 degrees, we're going to start by looking what direction on this one. Remember, all of our angles have to be acute, so I would have to start by looking south first. Then I'm going to rotate back, meaning to the east, what angle amount? Remember, since this is a 90-degree angle, then the unknown one that we're trying to find and 42 are complementary. So we're just going to take 90 and subtract 42, and we would get 48 degrees. Pretty simple stuff, but again, in order to do all of the things that we're going to end up doing with these, we have to be able to just start by either recognizing and knowing where that point is or direction we're supposed to be headed in either method 1, just given an angle, or method 2, given the direction to start, the angle to rotate in the direction that we want to be headed. So 257, again, we are in the southern hemisphere to start, right? Notice this was in the northern, this one was in the southern, this one is in the southern tip, okay? So the southern hemisphere on this one is where we're going to start. We're going to have to rotate from the south a direction of, I already found it, 77 degrees. And again, that's why I told you to label as much as you possibly can. And we went in the western direction, that 77 degrees from the south. Okay, last one here, 315. Notice to get to that, we would be in the northern hemisphere, the upper half. So we're going to start north, and we're going to rotate to the west 45 degrees. All right, so pretty simple. Just, it's going to take some practice for sure. Don't get frustrated by it. Make sure you understand the difference between method 1 and method 2. I won't necessarily say method 1 or 2. You just need to recognize that this is equivalent to that, for example.